Good morning, y'all. So continuing our lessons with simplifying radicals. We've already looked at simplifying plain old square roots, and then the other day we looked at what happens when we have variables inside of our square roots. Today I want to examine what happens when our index isn't 2. Now, I do want to kind of jump to this other page that we had, the parts of the square root. Remember when we were identifying these in class? So this here, this would be our coefficient. These are just numbers that are in front of our radical that are going to multiply with whatever is coming out. The inside part, we call that our radicand. And then this part, this little number that hangs out above the radical, this is what I'm talking about today. So this is the index of our radical. So that's really what we're going to be examining today, is what happens when that's more than 2, because we've only been talking about square roots. So back to this phenomenon, what happens if the index isn't 2 anymore? Well, what we're going to do is we're going to find groups, find groups of the index to take out. And this is referencing our factor trees. Remember, if our index is 2, or if we're doing a square root, or we're doing a factor tree, we circle pairs. So, as an example, if the index is 3, or it's a cube root, circle groups of 3. So we're still going to use the same practice of breaking down a radical using factor trees. We're just going to do it using different indexes now. So the cube root of 32. If I break apart 32, I know that's divisible by 2. So it would be 2 and 16. And then from 16, I'd have 2 and 8. And then from 8 is 2 and 4. And then from 4 is 2 and 2. Now, here's what's different about these problems, is that because my index is 3 here, I'm going to circle groups of 3. So notice that I've got these 3 2's hanging out here. And even though I have a pair of 2's that are left over, because it's not in a group of 3, referencing my index, it can't come out of our radical. So the 2 comes out, and what would be left over are these 2 2's that are over here. So 2 times 2. So our answer would simplify to 2 cube root 4. And again, the reason being is because I had this group of 3 2's here. So that's the 1 2 that came out. And then because I had these 2 2's left over, I would have 2 times 2, which gives me 4. Let's look at another example here. So we have the 4th root of 32, so let's look at how this is different. So I'm going to break it up the same way. 2 and 16, 2 and 8, 2 and 4, 2 and 2. Now, because my index is 4, I need groups of 4. So I'm circling all 4 of these 2's here. There's 1, 2, 3, 4 there. So that 2 is what comes out. And then because it's a 4th root, you need groups of 4. This 2 is a loner here, so the 2 remains. So my final answer is 2 4th root of 2. Let's look at some more examples, because those are using the same number, so I want to do this a couple different times, looking at different numbers. Again, we're always referencing what happens when our index is greater than 2. For the most part, as we've been looking at these problems with simplifying radicals, when we don't see a number that's there, it's implied that it's a square root. So it's implied that your index is 2. That's why we're always circling pairs. So I'll do this example here. I want the cube root of 40, so if I divide it by 2, that's 20. That'd be 2 and 10. with 2 and 5. Again, because my index is 3, I'm going to take these 3 2's here. So 2 comes out, and then this 5 is by himself, so he's going to remain inside the cube root. So 2 cube root of 5 would be my answer. Another example, the cube root of 16, so that's 2 and 8, which is 2 and 4, which is 2 and 2. So again, cube root, I'm looking for pairs or groups of 3. So here's a group of 3 right there. So the 2 comes out. This 2 is left over. So that's going to remain inside of my radical. So my answer is 2 cube root of 2 if I'm simplifying the cube root of 16. Number 3 here, let's simplify the cube root of 48. 2 and 24, 2 and 12, 2 and 6, 2 and 3. So breaking it all the way down, again, index is 3, so I want groups of 3 here. So I've got this group of 2's, and then the 2 and the 3 are still left over. So the 2 comes out, and then inside of my cube root, I would still have this 2 and this 3, so it'd be 2 times 3, still on the inside, which means that my final answer would be 2 cube root of 6 after I simplify. I think this is another cube root problem. So the cube root of 81, let's break this down. So 81 is actually divisible by 3. So I'm going to divide that by 3 and get 27. And then 27 is divisible by 3 as well. That's 3 and 9. And then 9 is 3 and 3. So cube root means circle groups of 3. So I've got those 3 3's there. 3 comes out. And then this leftover 3 remains inside my radical. So my answer is 3 cube root of 3. Now, all of these problems that I've showed you here, those are all using index of 3. I'm going to start looking at a couple different index problems. So like the 4th root of 48, I think we already did the cube root of 48, but let's look at the 4th root. So that's 2 and 24. That's 2 and 12, which is 2 and 6, which is 2 and 3. So again, because it's a 4th root, I'm taking groups of 4. So 1, 2, 3, 4 there. So there's my 4. So that 2 comes out. And then what remains has to stay inside of a radical. That's this 3 here. So it'll be 2 4th root of 3. And then this next one, I believe, is using the index of 5. So 96, I know, is divisible by 2. So I'm going to divide that by 2 and get 48. And then 48 is divisible by 2. That's 24. 24 is 2 and 12. I think some of you might see how this is going already. 2 and 3. So here, my index of 5 means that I've got 5 here that I need to circle. 1, 2, 3, 4, 5. So that's my number that comes out, is that 1, 2. And then whatever remains is still inside the radical here, 3. So I get 2 5th root of 3. And then finally, couple last problems here. If there is a coefficient in front of your radical with a different index, it still applies the same rules where you're going to multiply that coefficient by whatever is coming out. We're just working on the simplifying with different indexes. So that's 2 and 16, which is 2 and 8, which is 2 and 4, which is 2 and 2. Lots of 2's. 2's and 3's happen a lot when we're changing indexes. So index of 4, 1, 2, 3, 4 here. That's the 2 that comes out. And then left over inside of my fourth root, I still have this 2. But from the beginning, there was a 7 that was out here. So that's going to multiply with whatever came out. So it'll be 7 times 2 with fourth root of 2. So a final answer of 14 fourth root 2. And we have one more example for good measure here. So negative 2 cube root of 56. We haven't seen 56 yet, so that's fun. So I've got 2 and 28. And then 2 and 14, which is 2 and 7. And 7's prime, so I can't really go anywhere with that. Cube root, again, we're taking a group of 3 here. So I've got these 2's. That will come out. This 7 is left over, and it's still inside of my cube root. The only thing that's different about this problem is that I have this 2, this negative 2 from the beginning, so that is going to multiply with that 2 that I brought out. Lots of 2's in this problem. So negative 4, the cube root of 7 would be my final answer. So these are a couple examples of how you can simplify a radical when we're changing index. Remember, the main rule is that whatever your index is, that little number that's hanging out above the little joint in the radical, that's the number of group, or that's the group number that you're going to be bringing out. So because my index in this problem was 3, I was taking out 3 2's rather than just circling pairs like we have been in the past. So make sure you like and subscribe to all my videos here. I'll post these as much as I can when we have different material. Other than that, have a great day. Hope to